Problem number 22. Two rockets are in space in a neglectable gravitational field. All observations are made by an observer in a reference frame in which both rockets are initially at rest. The masses of rockets are m and 9m. A constant force F acts on rocket of mass m for a distance d. As a result, the rocket acquires a momentum p. If the same constant force F acts on the rocket of mass 9m for the same distance d, how much momentum does the rocket of mass 9m acquire? So we need to find what is p prime. So to solve this problem, we need to check that if a force acts, same force acts on the same distance, it means that both rockets they are getting the same kinetic energy, and the kinetic energy has this expression 1/2 mv square, which we can write through momentum p square over m. From this we can find that momentum equal root 2km, and if we look to this expression, kinetic energy is the same, but mass was increased 9 times. It means that momentum was increased 3 times. So D is the correct answer. Problem number 23. If a planet of radius r spins with the angular velocity omega about an axis through the North Pole, what is the ratio of the normal force experienced by a person at the equator to that experienced by a person at the North Pole? Assume a constant gravitational field G, and that both people are stationary relative to the planet and are at sea level, and assume they have, of course, the same mass. It's obvious that on North Pole we have a normal force equal to gravity force, because this person is not moving, it's stationary. So we have normal force equal mg. On equator, person going by circular trajectory, and we know that in this case we have centripetal acceleration with a centripetal force equal mr omega square, and if we have normal force n and gravity force mg, so we can say that this force is a result of n and mg. So we have mg minus normal force equal mr omega square. So from here we can find that normal force equal mg or minus mr omega square, and we have n over mg equal 1 minus r omega square over g. So that's correct answer, which is C. Problem number 24. A ball of mass m is launched into air. Ignore air resistance, but assume that there is a wind that exerts a constant force F0 in a negative direction, negative to x. In terms of F0 and the acceleration due to gravity, at what angle above the positive x-axis must be ball launched to order to come back to the point from which it was launched. So to solve this problem, we can just make a picture and see that resulting force mg and F0 is going this way. So that will be our efficient force, like efficient gravity. So we know that if we want to launch any object back to us, we need to throw it exactly opposite to this resulting force. So we need to find what is this angle. And from this picture we see that tangent of this angle equal mg over f0, and correct answer is this one. Problem number 25. Find the period of small oscillations of water pogo, which is a stick of mass m in the shape of box, rectangular parallelepiped. The stick has a length L and width W and a height H, and is bobbing up and down in water of density ρ. Assume that the water pogo is oriented such that the length L and the width W are horizontal at all times. Assume that all equilibrium the pogo is floating. So to solve this problem, we just need to write equations. What is the force when we move this box a little bit down on distance x. So we can write equation right away. Ma equal, so we have Archimedes force, which is going up, so it's negative compared to displacement, and Archimedes force equal to weight of displaced water, which is ρ L W x g. So this is our equation for motion. We can rewrite it in form of A equal negative ρ L W g over m x. We see that acceleration proportional to displacement and always going back to displacement. That's a regular equation for simple harmonic motion, and we know that in this case this coefficient is exactly omega square. So we have, from this we have period equal to pi root of m over ρ L W g. So this is the answer. Here we have from the left side we have many different answers, but correct answer is D, this one.